Good evening. My name is Tran, and today I am going to presenting my projects for EEL 4304 lab class, the peripheral hardware controller. This project is a small portion of our final design projects. The reason why I use this one to also demonstrate in the electronics to lab class is because this is have a huge relationship to the uh, the class. Um, this one also use BJT and MOSFET to make to create a circuit to regulate the temperatures of the hot end. So let's begin. Through the use of an end effector which extrude materials such as fiberglass, a robotic arm can be used to automate manufacturing in fields such as the marine industry. In order for the printer head attached to the robotic arm to function properly, settings such as the extrusion rate and the temperatures of the hot end must be controlled. This project develops a peripheral hardware controller which can be adjusted and control these settings during the printing process to ensure the proper functioning of the device. The objectives of this project is monitor variables such as hot end temperatures and extrusion speed in lifetime, achieving printing results in good quality. Adjust variables as required during the printing process. Now let's come to the project descriptions. To help the develop an automated fabrication system, our project developed a peripheral hardware controller for a continuous fiber extruder. This controller is necessary because fiber extrusion printing require monitoring and adjustment for certain variables during the printing process. The continuous fiber extruder is attached to a robotic arm or hardware controller, allow for the control of the system and the arm simultaneously and remotely. Now let's come to the project video demonstrations.
Hello everyone, I am the photometrist and behind me are the Kuka VR tank. Here we have a peripheral hardware controller. Each one of these switches will turn on each component of it. There's the fan switch, there's the temperature sensor switch, there's the motor switch, and there's the master switch for safety. This display will show us the temperature of the extruder, and this will show us the DC motor speed and power cycle. With this knob, we'll be able to control the temperature of the extruder, and with this knob, we'll be able to control the motor in which the extruder will be processing. This button will do the counterclockwise, and this will be the clockwise version. If we need to stop it, we'll press the red button. Each slide here will indicate when each component is on. Thank you for watching.
So this is the 3D printing mechanism block diagram. So as the power is generated, the goes to a smart part at the smart pad, and the smart pad will generate the robotic arm and the filament distributor, which then process the printing padding, the robotic padding, and the extruder. The executable command and the filaments also toggle the peripheral hardware controller, which is able to regulate the temperature of the cooling mechanism and the positions of the controller. The temperature and the cooling mechanism is work for the heating and fanning, and then can regulate the PID controller. The positions controller is able to monitor the extruder and then the rotational and the speed controller. Then this come to the 3D printing products. This is the process of it. Now let's come to a DC motor speed controller. The DC motor speed controller will have the following components. the motor driver, which is connected to the spool of the DC motor. Um, this is the Arduino, and the power supply 24 volts. Then we use the step down 12 voltage to connect it to our circuit. Here we have three buttons, which is to dictating the directions of the DC motor. Another one is to stop, and another one is to move forward. The turn right here is to dictate the speed of it. And we also have an LCD display to show the speed of our motor so we can control it accordingly. The speed we set is medium because mainly we control the spool that speed the resin into our extruder. Now let's come to the temperature control. The PID temperature control, we have the components as the Arduino Uno, the K-type, the K-type thermocouple, the Maxwell 6675, the rotary encoder, IL2C LCD, IRF Z44N MOSFET, SA05A50 BJT, 10K ohm resistor, four of them, and the hot end and 12 volt power source of our USB. So now we connected to the LCD and the rotary encoder and a Maxwell 6675, the MOSFET and the BJT to regulate the temperatures. The Maxwell 6675 is used as a thermocouple to sense the hot end temperatures during the printing process. When the temperature is high, the MOSFET and the BJT will regulate the temperatures to make sure it stays in the range of desired temperatures. Also, we could use the rotary encoder to manipulate the temperature as we want it to go higher or lower. Now let's come to the fan design. The fanning portions is very simple. This is the simple circuit of the fan. You can see it's only include wires, LED, and the fan, and a simple source. And the portions of the fan, there is a switch to toggle the fan on and off connected to an LED. So when an LED is turned on, the fan is also turned on, and vice versa. Now let's come to the master switch design. Here, there is a master switch that can turn on and off all the functions. There's a master switch that attached to the DC motor speed, which is enabled, and another one is for the temperature regulate switch. And the final one is for the extruder fan switch. These are used to regulate the temperatures, the printing process, the speed of the fiber extruding robotic arm. So in conclusion, this was created for the safety considerations and emergency shutdown. It is used because when it comes to robot, there could be a fault in the system that can cause it to harm the pupil in the experiment. So when anything occurs, it is essential to have something to control, to direct control over it, to immediately stop it. Another reason is to increase the quality of the finished product by adjusting the product variables. This small projects can be able to regulate the temperatures, the hot end speed, the fan portions, which is enough for the peripheral hardware control system. The benefits of it is have a variables such as the safety reasons, the fast controlling, and easy to access to a non-linear 3D printing. Thank you for listening. Have a great day.